IIT Guwahati researchers present new clues to understand the mechanism of supernovae. First of its kind simulation study conducted by the researchers reveals new facts about the fast flavor conversion of neutrinos.
When a massive star runs out of its fuel, it collapses under its own gravity and results in an immense shock wave. This shock wave gives rise to a huge and luminous explosion called supernova. For astrophysicists, this event is of particular interest as such explosions are considered to be the cradle of birth for new stars and also for the synthesis of heavy elements in nature. But the mechanism of these super explosions is not yet completely understood and has remained one of the enigmas of the universe. However, scientists think that this mechanism can be understood by studying the tiniest subatomic particles called neutrinos, which are released during a supernova in large numbers. Neutrino is actually a neutral subatomic particle with a negligible mass. It is very much like an electron, but it doesn't have any charge. Considered to be one of the basic building blocks of our universe, neutrinos exist in three forms or flavors: electron neutrino, muon neutrino, and tau neutrino. And during a supernova explosion, neutrinos of all flavors or types are emitted in a large number and with a powerful flux. Till now, for studying the process of supernova explosion and the accompanying neutrino emission in a simpler way, scientists have been classifying neutrinos in two groups: electron neutrinos and non-electron neutrinos, which clubs muon and tau neutrinos as one, as scientists assume that these neutrinos are identical, as they have identical fluxes. But according to researchers belonging to the Department of Physics at IIT Guwahati and their co-researchers, this assumption is not right, as many studies show that under high density, neutrinos can change forms or flavors. Which means electron neutrino can become muon neutrino and muon neutrino can become electron neutrino at a very high rate. Researchers from IIT Guwahati collaborated with researchers of Max Planck Institute for Physics, Munich, Germany, and the Northwestern University, USA, and abandoned the usual two-flavor approach. They performed non-linear simulation of the fast flavor conversions, including all the three types of neutrinos inside the supernova. They demonstrated with their study that inside the supernova, non-electron neutrinos can have different fluxes, and therefore one needs to consider all neutrinos as separate entities to study supernova precisely. According to the researchers, three flavor studies changed the results dramatically in comparison to the existing two-flavor results. This can have major implications for particle and astrophysics of supernovae neutrinos. The study has been published in the journal Physical Review Letters.